Newton's first law summarized says that if there is no net force, then there is no change in velocity. In other words, remember, changing in velocity is acceleration. So that means acceleration depends on the net force. Or as I like to write it. So now, but acceleration also depends on the amount of mass, because mass resists acceleration. Mass resists change to its state of motion. Resists acceleration. So if mass resists acceleration, but forces cause acceleration, we can put these two together and give us that acceleration increases as the amount of force increases on it, but decreases as mass increases. So this is Newton's second law. Now, you know it if we do a little bit of algebra magic. Whoops, forgot my little sum finally. Do a little algebra magic, and this means the sum of the forces that are on an object will equal the acceleration times mass. So now, let's take a look at what that means. Oh, it means my pen is bleeding through my paper. So if I have 2 kilograms of mass accelerated at 5 meters per second squared is going to give me how much force? Well, that's 10 kilogram meters per second squared. The kilogram meter per second squared is given a new name. It's called the Newton. When you write it out, it's lowercase. However, when it's short, it's capital N, because it's somebody's name. And it has to be the sum of all the forces. Let's take a look at a car. Here's you. Here's your car. Where'd your car go? Must have done. Here's your car that's now broken down, and you have to give it a push. So you're going to push it with 275 newtons of force. The mass of your car is 1,850 kilograms. You can't push it very hard, so you have your friend come over, and your friend's going to help too. He's going to push it with a force in that direction of 395 newtons. What's the acceleration of your car? Well, the sum of the forces on it is going to equal mass times the acceleration. What are the sum of the forces? Oh, wait, there's something else pushing back on it. You have some sort of opposing force of about 560 newtons. So let's look at the sum of our forces. We have direction. This way has to be positive. It doesn't have to be. So I am going to have 395 Newton force plus a 275 Newton force minus 560 newtons, and that's going to equal the sum of my forces. So we end up with 5 plus 5 is 0. 5 plus 5 is 0. 7, 6 minus 560 gives you 110 newtons for the sum of my forces, and that's equal MA. 110 newtons equals 1850 times the acceleration. My acceleration is going to be 110 divided by 1850, which is, this is a positive force, this is positive, which gives me plus 0.059 meters per second squared.